So in this question, there is a satellite. Okay, so its mass is m, is launched vertically upwards with an initial speed of u from the surface of the earth. After reaching a height r, we are having an earth. So let the radius be r. So இங்க இருந்து launch பண்றாங்க. It is going to some height and then it is ejecting a rocket of mass m by 10. இங்க வந்து m, இங்க it is ejecting m by 10. Eject பண்ணதுக்கு அப்புறம் what is happening? It is moving in a circular orbit. அப்போ after ejecting, okay, so 1 by 10 is went here. அப்போ here 9 by 10 m is moving in a circular orbit. Okay, அப்போ here what will happen to the rocket? Rocket will gain what? A velocity in this direction. அப்போ அவருக்கு எப்படி இருப்பார் அப்படின்னா, here it will have some tangential velocity, at the same time it will have some radial velocity. Okay, so that I'll write in this direction. So it will have some radial velocity, correct? And then, so what is the kinetic energy of the rocket? So if you want to find the kinetic energy of the rocket, it has both the component. Okay, radial component இருக்கும், tangential component இருக்கும். So this is actually half mv square, but this v is what? This v is your tangential component plus your radial component. Okay, so maybe இங்கே தான் மிஸ் பண்ணியிருப்பீங்கன்னு நினைக்கிறேன். Okay, அப்போ tangential component and your radial component we have to find separately. Okay, so that we can find. Okay, so that we can find. So first நமக்கு தெரிஞ்ச orbital velocity formula என்னது? That is actually root of gm by r. Okay, so by r. So this is nothing but your tangential velocity, tangential orbital velocity. சரி, இப்போ first we can fix your tangential velocity. Okay, so அங்கே இப்போ என்ன பண்ணலாம் அப்படின்னா, ஸோ இங்கிருந்து அவர் மேலே போகிறார், ரைட்டா? அப்போ here it is moving in vertical direction initially. அப்போ initially it has only vertical velocity. அப்போ இங்கே வந்து it is like what to say, ஒரு பாம் ரெண்டாவோட blast ஆகி ரெண்டு பீஸாக போதில்ல, like that if you consider, here we can apply what? Your conservation of linear momentum. Okay, so in tangential direction I am writing. Okay, tangential direction. Okay, so momentum before the splitting will be equal to momentum after splitting. Okay, so momentum after splitting. So இப்போ tangential direction மட்டும் பார்க்கலாம். So in tangential direction if you see, it is initially moving only in this direction. அப்போ tangential direction there will be no velocity. அப்போ in tangential direction initial momentum is 0, correct? It's having only radial velocity. அப்போ final momentum will be equal to what? இவர் இங்கே blast ஆன உடனே ராக்கெட் இப்படி போகிறாரு. Okay, tangential, I'm talking about only tangential. Okay, so satellite இப்படி போகிறாரு, ஒரு ராக்கெட் இப்படி வராரு. So it has opposite velocities. அப்போ what I can write? So mv minus mv. அப்போ ஃபஸ்ட்டு ராக்கெட்டுக்கு எழுதணும் அப்படின்னா, so that is m by 10 into tangential velocity of the rocket minus satellite 9 by 10 m. So that is tangential velocity of the satellite, that is nothing but orbital velocity. So root of gm by what is the radius? இங்கே r, இங்கே r மேலே போயிருக்காரு, அப்போ r plus r you will get 2r. So you will get 2r. Okay, this is what we will get. Okay, so here if you do this math, what we will get? m by 10 vt will be equal to 9 by 10 m root of gm by 2r. So here m we can cancel, 10 we can cancel. So director, this tangential velocity of the rocket we are getting. So that is what? That is 9 into root of gm by 2r. Okay, so this is what we are getting. சரி, அடுத்து we can come to radial direction. So if you come to radial direction, okay, so radial direction, so initially it is rocket is moving here. Okay, அப்போ initial radial momentum is there. Okay, I cannot say it is 0, but final if you see, so final radial momentum of the rocket. Okay, so only for rocket if you write, what we will get? So here this is my satellite with rocket before blasting. Okay, before firing. அப்போ இனிஷியலாக இந்த பக்கம் வெலாசிட்டி இருக்காரு, that is what? v. So என்டையர்லாம் பார்த்தீங்கன்னா momentum is m into v. Here it is going to eject. Okay, radial மட்டும் பேசுகிறோம். Okay, if you talk only about radial, okay, it is moving in this direction. Okay, so the arrow mark மட்டும் மேலே வரைஞ்சிருக்கேன். If it is ejecting some rocket, it will eject one radial, eject the rocket in this direction. So in the vm இங்கே போட்டுடலாம். So m into v, initial momentum, this is initial radial momentum. So after ejecting, what will happen? So this will be your rocket m by 10, இவர் இந்த பக்கம் வருவார். கரெக்டாக? ஸோ இவருடைய velocity நமக்கு தெரியாது. Let it be vr. அப்போ here before is this, final is this. அப்போ according to angular momentum conversion, both of them should be equal. அப்போ what I can write m by 10 into your radial velocity will be equal to your m into v. Okay, this is what we are getting. அப்போ here vr is nothing but m தூக்கிடுங்க, v by 10. Okay, it is v by 10. So now we have to find what is this vr. Okay, so இங்கே gmல இருக்கு in terms of இந்த v நமக்கு தெரியாது. So first we have to find vr, this v, and then we can substitute. அப்போது இங்கே லான்ச் பண்ணும்போது இங்கே போகும்போது what is the final velocity of the entire system along with rocket and satellite, that we have to find. ஸோ அப்போ அதுக்கு என்ன பண்ணலாம் அப்படின்னா energy conservation to find this v. So if you apply energy conservation, what we will get, so if you apply energy conservation, so initial energy of the satellite will be equal to final energy before firing, it is final. So potential energy will be equal to what? Minus gmm by r. M on the mass of the earth. Okay, so plus half m initial velocity is u square will be equal to final velocity, final energy, that will be equal to half m v square. இந்த v தான் நம்ம கண்டுபிடிக்க போகிறோம். Minus gmm by, so it went to a distance of 2r. correct? Yes, 2r. So now it is 2r. So now we have to find what is this v. So இங்கே gm by r, gm by 2r. Okay, so இவரை first subtract பண்ணிக்கலாம். So here if I bring this here, I'll get plus half. correct? Minus 1 plus half. So minus 1 plus half means minus half. I'll get minus half gmm by r, which will be equal to, so இவர் அந்த பக்கம் கொண்டு போயிட்டுனா I'll get what? Half m v square minus u square. So we can cancel this half m. So what I'll get then? So v square will be equal to u square plus gm, minus. So minus gm by r. So this is what I will get. நமக்கு தேவை v, அப்போ இவரை தூக்கிட்டு ரூட்டை போட்டுக்கலாம். ஓகே, ஈக்குவல் டு போட்டு ரூட்டை போட்டுக்கலாம். ஸோ u square minus gm by r. So this is what we are getting. அப்போ here we have to apply. This is how much? This just now we got. This v is nothing but root of u square minus gm by r. 1 by 10 we can write here. So this is what we are getting. So இப்போ kinetic energy நம்ம கண்டுபிடிக்கணும். So here I don't have space, இதை erase பண்ணிக்கலாம். So here kinetic energy. So kinetic energy is what? Half mv square, half m tangential square. If you square this, what we will get? 9 9s are 81. So into gm by 2r plus, okay, so if you square this, I'll get 1 by 100. Okay, so it is 1 by 100 into u square minus gm by r. So this is what we will get. Here we made one mistake. Radial acceleration is 10 into v. So here this is 10. This is 10. So this 10 will be here. Okay, so now here you will be having multiplied by 100. Okay, so now this will be equal to, now what can be done? So here we have to simplify this. Okay, we can see the option. So 3m by 8, m by 20. So m by 20 we have, m by 20 we have, or 5m or 3m. We have to reduce this. Okay, so here first we can subtract this. Here so if I take 5 or 9, so okay, multiply everything and we can check what we are getting. So 1 by 2 m. So here this is nothing but 81 gm by 2r plus 100 u square minus 100 gm by r. Okay, so we are getting this, and then what we can do here, this 2 if I multiply here I'll get 4. Okay, so here I have 100 u square. So first gm by 2 r, gm by 2 r, we can fix this first. Up 1 by 2 m, so 100 u square. If you subtract this, LCM will be 2r, so here 200. So 200 minus 81, we will get 119. So minus 119 gm by 2r. Am I right? This is 2r. So we are getting this. So and then, so again we can make it as m by 4, 200 u square minus 119 gm by r. So this we are getting. So u square la enna irukku paakalam. So you have only u square. Okay, அப்போ u square மட்டும்தான் இருக்குன்னா 200 காமனாக வெளியே எடுத்துருங்க, முடிஞ்சு போச்சு. Okay, if you take 200 in common, what you will get, 200 வெளியே காமனாக எடுத்திங்கன்னா it will get m by, so 200 if you take common you will get 5m. Okay, 5 4s are 20, so 5m you will get u square minus 119 gm by, so here 200 r. Okay, so 5m 200 by r, so 5m இங்கே இருக்க பாருங்க. This is what answer is.